You're welcome back again. So we want to begin to look at some of these unsupervised learning algorithms that we mentioned in our previous class. We want to start with k-means clustering. Under clustering, so one of the simplest and the fastest algorithm for clustering. It's one of the most widely used algorithm due to this applicability to a wide range of uses. K-learn is used in many areas, and because of ease of implementation and also speed. Okay, and also it is a central-based algorithms that divides the data into K clusters. Each cluster is assigned a centroid, this is the center, and each data point is assigned to the cluster based on the closest centroid. This process is iterative because the centroid positions the center to the center of the new cluster until the final cluster is obtained. From introduction we explained the other time, you can see from my introduction. So this is called clustering. So we want to look at how do we implement K clustering quickly. So we're going to use a reset data set to try first. Then we can now use other data set. So this one we have used several times. So I can just run it as usual. This is our data set erase. Okay, so which we are familiar with properly because we have used it several times. So we're going to reprocess it now by standardizing it, right? Because it's very sensitive to scaling. All right, so now we are going to look at a number of K we want. So there are several methods to detect number of K. One of the common methods is called elbow method. Maybe in the next class, we are going to look at various methods of those K. We now choose the one you prefer among the methods, but I will just look at a elbow method here only for now. So this is how you just process elbow method using within cluster sum of squares. So we're going to run this. Don't mind the warning session there, okay? It's because of the some depreciation of a listen there. So as I run now, if you can see down here, it's loading. So this is elbow method. Now look at elbow from here down like this. So where the points begin to normalize down, into straighten down is called the elbow. So here we pick three here, the first, second, and from the third point here begin to normalize here. This is called elbow method. Other methods are not the same, so but at least this elbow, that's called elbow method. Okay, that at the point 3 begin to normalize, begin to straighten, and it's called elbow method. So our K will be 3 now. Okay, 3. All right. So we say okay, apply K means with 3K. So in this case now we supply our cluster to be 3. All right. So we pass our other parameter random state with the 2. So we fit in our SK, which is our X feature we have scaled. We fit in now. So we now print some head, in which we saw here now. So we print some head here. Then also we can visualize our 2D projection now, which I've just run here. All right. You can see how it looks like. So this is our 2D projection. All right. You can see this first, second, third. All right. So this is what we have. All right. So that is for K equal to 3, right? So you can also look at this. You can change this for separ width, and this for separ length. You can change it, okay? Because if you look at what we are paying, that we are paying 0 and 1, which means column 1, column 2. Don't forget that is a separ width and also separ length. So you can also, if you check here, you can see that this separ length, this separ width. So you want to choose another columns, petal, for example, petal length and petal width. You can do that also. All right. So that will be this column 0, column 1, column 2, column 3. Okay. Take note of that. So you can see the code here, how we generate just titles label, title, and so on to show the legend here. This centroid. For centroid, we use a star here to show our centroid. Can you see? Everything is adjusting and trying to concentrate on the environment of the star, where the star is located. So you can see them, okay, running towards star. So the meter is in the middle of each of the data. So now you can also evaluate the code by looking at if you evaluate here, you can see here, you can print our score 62% here. This is the score we have, and we show matrix we have here, right? So k-means misclassify some samples, okay, e.g. confused iris for its color and iris for gender, okay. You can see there. We also have adjusted rand score. Clustering aligns moderately with a true species. All right. So limitation of this clustering is that it assumes spherical cluster of similar size, and it also struggles with complex shapes. So in that case, we use what they call DB scan for such cases. All right. So let's use another example to see how this is. So this time we're going to use generate a 2D data set containing 4 different blobs. And after that, we apply k-means algorithm to see the results. Okay, so data set is from make blocks. So just run this line of code. Then we can now use our able method again. Let's select our number of k. So if I run this now, we can also select number of k here using the same method we have used before. All right, so it's nothing change here. We just pass in our x. This time around is our x we are passing in now, not xk. Here we don't scale anything. So we can see scale actually, but just to waste our time. So just so this is our s value. This is our y true. So now we want to see the able. It's loading. So this is able method now. You can see here. So you can see here, here. So at this point now, we begin to normalize here. Okay, this is part of the able, but it begin to normalize from this point. So this point now is number 4. Okay, this able method now 4. So we can take four cluster now. Okay, you can see this normalization points. All right, so that the former one is different from this one. All right, so we choose a equals to 4 at this point now. So now you can print, you can visualize the, the plots here. So you can see our k equal to 4 here. So we are using our just a circle here, not a star anymore. Okay, so as k is equal to 4 here, you can see them here, see them here, see them here. So this is what we have here for this particular data set. Okay, so they are all trying to run around the cluster here. Okay, so you can also print computer matrix as well here. So this is why we are separated, and you have in 1.0. Don't mind the data set; it's not a proper one. So, but we just at least use for demonstration purpose only. So this is just how to pick your k and how to run case clustering. So it's as simple as that. So, but in the next class we look at a different method of discovering or getting our k. So for now, I'm going to stop here for now. So we meet in the next class as we look at a more this thing. So thanks so much for listening. You can like and share, you can comment if you want, and I really appreciate you so much. So bye for now. See you later.